Beneath the waves lies a discovery that could shatter our timeline of human history. This is the story of the underwater rock formation that divides geologists and archaeologists, a submerged enigma where science itself is split in two. By the end, you will understand the core evidence for both sides and decide for yourself if we are looking at a geological masterpiece or the ruins of a forgotten world. We will examine the strange right angles that seem too perfect for nature and the ancient legends of sunken lands that this site brings to mind. Does this structure reveal a lost chapter of human ambition, or is it a stunning trick of the elements? Their instruments painted a picture that defied all expectation. On a routine survey off the coast of Japan, a team of marine researchers watched their sonar screens fill with a startling image. Instead of the expected, gently sloping seabed, the scan revealed sharp angles and flat platforms. A colossal structure, later named the Yonaguni Monument, rose from the ocean floor like a forgotten citadel. It was a moment of pure scientific dissonance. The human mind is trained to seek patterns, to see faces in clouds and castles in rock formations, but this was different. The scale was immense, a monolith of sandstone over 80 feet tall. The features were bewilderingly precise. What they were seeing appeared to be a series of massive terraces, sheer vertical walls meeting flat surfaces at crisp 90-degree angles. There were what looked like staircases ascending the sides, and even two prominent pillars standing side by side, as if guarding an entrance. The initial reaction was not excitement, but a profound sense of confusion. The ocean is the realm of the organic, of flowing curves and chaotic erosion. This was geometry, this was order. The discovery immediately posed a single, haunting question. Were they looking at a masterpiece of natural geology, sculpted over millennia by relentless currents, or were they the first people in thousands of years to lay eyes on a sunken piece of human history? This anomaly, lying in waters just 80 feet deep, instantly became a global archaeological flashpoint, a riddle written in stone on the ocean floor, daring anyone to solve it. For those who see the Earth as its own greatest artist, the explanation is clear and grounded in immense spans of time. This perspective does not diminish the monument's awe, but relocates its origin story from human hands to the planet's own restless machinery. The region surrounding Yonaguni is one of the most seismically active on Earth, a place where tectonic plates grind against one another with colossal force. Over countless centuries, this relentless pressure has fractured the bedrock itself. The sandstone that forms the monument is not a solid, uniform block. It is layered like a stack of sedimentary pages, and these layers have natural points of weakness. Geologists point to a process called sheet jointing, where immense tectonic stress causes the rock to crack along these pre-existing planes. The result can be astonishingly clean breaks, producing sheer vertical faces and flat, level platforms that meet at crisp angles. What we perceive as a carved staircase in this view is simply the handiwork of differential erosion. Imagine a layered cake where the frosting between some layers is softer than others. Over eons, water currents act like a slow, persistent finger, scouring away the softer material first. This leaves the harder layers protruding, creating a series of natural, stair-like ledges descending the structure's face. The two iconic pillars could be explained as harder cores of rock that resisted erosion while the material around them washed away. From this standpoint, the monument is a spectacular example of pareidolia, our brain's powerful tendency to impose familiar, human-made patterns onto natural randomness. It is a masterpiece, yes, but one authored by earthquakes, ocean currents, and the patient, unimaginable weight of time. This geological narrative is elegant, testable, and fits within the established laws of how our planet shapes stone. It offers a complete and compelling story without requiring a lost civilization. But is that the only story the stones can tell? Yet for archaeologists, the stones whisper a different, far more human story. The geological explanation is powerful, but it struggles to account for the sheer density of seemingly intentional features clustered in one place. This perspective looks beyond the raw mechanics of erosion and sees the subtle fingerprints of design. Take the perfectly circular holes drilled into the upper terraces. Natural erosion rarely produces such clean, cylindrical bores in solid rock. To the trained eye, these look less like random pitting and more like sockets for wooden posts, perhaps for a structure long since vanished. Then there are the twin megaliths, two massive stone blocks standing side by side at the summit. Their placement feels deliberate, almost ceremonial, echoing the arrangement of monoliths at known ancient sites around the world. The most compelling argument often centers on the monument's apparent layout. Proponents point to what they call a star-shaped platform and a central altar-like structure, suggesting a spatial organization that serves a purpose. This isn't just a random assortment of interesting rocks, they argue. It is a complex. The arrangement implies planning, a communal intent that transforms a location from a geological feature into a potential place of gathering, ceremony, or even defense. This view naturally draws connections to humanity's oldest stories. Across the Pacific, legends speak of a vast continent called Mu or Lemuria, a sophisticated civilization lost beneath the waves in a cataclysmic event. Could Yonaguni be a physical fragment of those myths? The interpretation is ultimately about more than just dating rocks. It challenges the very timeline of human achievement. If this structure is man-made, it suggests that advanced seafaring cultures capable of such monumental stonework existed thousands of years earlier than our history books claim. It pushes us to consider a forgotten chapter, one where ancient mariners not only crossed oceans but built upon them. This isn't merely a debate over natural versus artificial. It is a question of whether we are looking at a remarkable coincidence of geology or the silent, submerged ruins of a world we thought was only legend. But one feature at the summit forces both sides to sharpen their arguments. High atop the main terrace, a large, triangular basin is carved directly into the solid rock. It is not a subtle mark. It is a deliberate-looking depression with clean, inward-sloping sides, and it sits in a position of apparent prominence. For geologists, this is not a mystery at all. It is a textbook example of a geological pothole. In nature, when a persistent whirlpool forms in a stream, it can trap pebbles and sand, creating a natural drill bit that grinds downward into the bedrock over centuries. On a monumental scale, with the powerful tidal currents that sweep through the Yonaguni Channel, such a process could absolutely sculpt this precise form. The ocean, in this view, is a master stoneworker with an endless supply of tools and time. Archaeologists observe the basin and see a different kind of logic. Its shape is remarkably regular. Its placement feels intentional, situated in relation to the terraces and platforms in a way that suggests purpose. They draw comparisons to known ancient sites, where similar carved basins served as vital reservoirs for collecting rainwater, or as quarries for extracting building material, or even as sacred pools for ceremonial practices. The key question they pose is one of probability. Is it merely a coincidence that this perfect geological pothole just happened to form at the apex of a structure already covered in so many other seemingly artificial features? Or does its presence complete a functional layout, turning a collection of shapes into a usable space? This triangular hollow is more than just a hole in the rock. It is a focal point where the two competing narratives collide most directly. One side sees the unmistakable signature of a natural process. The other sees the clear imprint of a human need. Interpreting this single feature forces us to confront the very framework we use to understand the past. Do we default to the known forces of geology, or do we allow for the possibility of human activity where our current timeline says it should not exist? The answer you lean toward here likely decides the entire case for you, and as we will see, this interpretive battle only intensifies when we look at the broader landscape surrounding the monument itself. The timeline of the ocean itself becomes the next key witness. To grasp the true age of the formation, we must step back into an Ice Age world. Roughly 20,000 years ago, the planet was in the grip of its last glacial maximum. Vast quantities of the world's water were locked up in colossal ice sheets, causing global sea levels to plummet. The difference was staggering. The shoreline stood over 120 meters, or nearly 400 feet, lower than it does today. This single fact transforms our understanding of the site. The spot where the Yonaguni monument now rests beneath 80 feet of water was not a seabed back then. It was dry land, a coastal cliff or plateau open to the sky. This geological timeline is the arena where both theories must operate. For geologists, this period offers a perfect explanation for the formation's initial shaping. When the site was above water, it would have been subjected to subaerial erosion. That is the powerful, familiar sculpting of wind, rain, and freeze-thaw cycles. These forces can create dramatic landscapes, carving away softer rock and leaving behind dramatic terraces and sheer faces. The monument's foundational features, they argue, could have been roughed out over millennia by these entirely natural processes. Then, as the glaciers melted and the seas slowly rose over thousands of years, the ocean merely finished the job, smoothing the edges with its currents until the structure was submerged and forgotten. This sequence fits neatly within established earth science, requiring no unknown actors. For archaeologists, however, this same timeline opens a door of profound possibility. If the site was dry land 20,000 years ago, then it was accessible to people. This period coincides with early human migrations across the region, a time when hunter-gatherer communities were navigating and settling new landscapes. The argument is not that they built skyscrapers, but that they could have modified a prominent natural outcrop for their own uses. They might have enhanced existing terraces for settlements, carved steps for access, or shaped stones for ceremonial purposes. The rising waters, in this view, did not drown a random rock formation. They slowly, silently engulfed a place of human significance, preserving it in a watery time capsule. So the sea level change is not just a date on a chart. It is the pivot point of the entire mystery. It either explains how nature could create such a spectacle entirely on its own, or it provides the exact window in which ancient hands could have touched the stone. The ocean did not create the debate. It simply hid the evidence, leaving us to decide whether it submerged a masterpiece of geology or a monument of humanity. The stones themselves hold the most intimate evidence etched into their very surface. To settle the debate, experts from both fields have leaned in close, examining the monument's skin under a forensic lens. The central question becomes a simple one of origin. Are the linear grooves, scratches, and striations covering the rock the signature of human tools, or the unmistakable fingerprint of the sea? Geologists approach this with the patience of someone who understands the ocean's workshop. They point to the powerful, sand-laden currents that constantly sweep through the Yonaguni Channel. In this environment, the sandstone is not just worn down, it is actively sandblasted. Grains of quartz, harder than the surrounding rock, act like countless microscopic chisels when carried by the tide. Over centuries, this relentless abrasion can carve parallel lines and channels into the stone, creating patterns that to our eyes look deliberately made. They show photographs of other naturally eroded coastlines, where wave action has produced strikingly similar sets of grooves and flutes. proving that nature is a master engraver all on its own. The argument is compelling because it relies on a visible, ongoing process we can observe in action today. Archaeologists scrutinize the same marks and see a different story in the details. They highlight specific areas where grooves do not run in the random, flowing directions of water currents, but instead intersect at sharp, consistent angles. They point to patterns that repeat with a regularity that seems to defy chance, suggesting a guiding hand rather than a chaotic force. If tools were used, they speculate, they would not have been modern steel. They might have been simple stone hammers and wooden wedges, or perhaps early metal implements, each leaving a distinct type of wear pattern on the relatively soft sandstone. This transforms the entire site into a kind of underwater crime scene. The rock face is the sole witness, and every mark is a piece of testimony. Geologists present the ocean as the culprit, a patient and powerful force with a clear, natural motive. Archaeologists suggest another suspect entirely, a culture with the knowledge and need to shape this place. We, the audience, are left to examine the evidence, to weigh the probability of a perfect natural simulation against the possibility of a human signal lost in time. It is a meticulous, almost microscopic debate, where the answer to a civilization's existence may be hiding in the angle of a single scratch. The debate over tool marks and tides inevitably leads us to a different kind of evidence, one written not in stone but in story. Our ancestors did not document sea level rise with scientific charts. They encoded the memory of cataclysm into myth. From the epic flood in the Mesopotamian Gilgamesh to the biblical story of Noah, and most famously in Plato's detailed account of a mighty island called Atlantis, cultures separated by vast oceans share a common narrative. It is the story of a great and prosperous land, often described as advanced or even idyllic, that was swallowed by the sea in a single, terrible day and night. These are not isolated tales. In the very region surrounding Yonaguni, among the Ryukyu Islands, oral traditions for generations have spoken of Nurai Kanai. This is not a story of destruction, but of origin. Nurai Kanai is described as a far-off, paradisiacal land beyond the horizon, a place from which the gods brought prosperity and life to the islands. For those who believe the monument is man-made, these legends are not mere fantasy. They are seen as a form of cultural memory, a distorted echo passed down through countless generations. Could the story of Nurai Kanai be a folk memory of a real coastal homeland, a place that slowly vanished as the waters rose over centuries, eventually existing only as a mythic realm beyond the waves? In this view, the Yonaguni Formation becomes a potential anchor for these stories, a physical place that gives weight to the whispers of the past. It suggests that our oldest legends might contain a kernel of geological truth, a record of humanity's shared experience with a changing planet. Skeptics offer a crucial counterpoint, warning of a seductive logical trap. They note that humans are innate storytellers. We see a face in the moon and a giant in a mountain range. Our minds are wired to impose narrative, meaning, and agency onto landscapes we find mysterious or awe-inspiring. A breathtaking natural formation, especially one discovered underwater, almost demands a legendary explanation. To conflate a compelling story with archaeological proof, they argue, is to risk building our understanding of history on a foundation of wishful thinking. Yet, even with this caution, the intersection is undeniably powerful. Whether the monument is natural or artificial, its discovery has reignited these ancient stories, giving them a new focal point in the modern world. It reminds us that our search for truth is never a purely scientific exercise. It is a journey guided just as much by the stories we have always told about who we are and where we came from. This cultural resonance adds a profound layer to the site, transforming it from a geological puzzle into a mirror, reflecting our deep and enduring desire to find our past in the depths. This intellectual stalemate reveals a deeper truth about the search for knowledge itself. The standoff over Yonaguni is not merely about a single rock formation. It is a vivid, real-world example of a fundamental clash between two powerful ways of seeing the world. On one side stands geology, a hard science built on the bedrock of quantifiable, repeatable processes. Its guiding principle is parsimony, often called Occam's razor. When faced with a mystery, the preferred explanation is the simplest one that requires the fewest assumptions. A geologist looks at a 90-degree angle and sees a clean fracture along a natural joint in the sandstone. They see a process that can be measured, modeled, and observed elsewhere on the planet. Their evidence is the physics of stress and the chemistry of erosion, forces that are beautifully predictable over vast stretches of time. The story they tell is one of an Earth that is its own greatest sculptor. On the other side is archaeology, a discipline that must navigate the messy, brilliant complexity of human behavior. Humans are not predictable like rivers. We build for reasons that blend practicality, spirituality, and social order, leaving behind traces that are often faint, ambiguous, and open to interpretation. An archaeologist looks at that same arrangement of angles and platforms and sees potential intention. They see a layout that might serve a communal purpose, a space organized for ceremony, shelter, or gathering. Their evidence is often circumstantial, built on patterns, context, and comparison to known sites. The story they seek is one of lost chapters in our own human journey. This is why experts can examine the exact same stones and see two entirely different realities. They are not just disagreeing on facts, they are operating with different rulebooks. A geologist points to a fracture pattern as proof of a natural origin. An archaeologist looks at that pattern and asks if it was utilized or enhanced by people. They are, in a very real sense, speaking different professional languages, and this can lead to a frustrating cycle of talking past one another. The divide is hardened by the high stakes involved. For archaeology, accepting Yonaguni as human-made would not just be adding a new site to the map. It would represent a paradigm shift, a dramatic rewrite of early human capability and migration that challenges established timelines. Such shifts are monumental and meet with natural, healthy skepticism from the broader academic community. Institutional inertia is a powerful force, as it should be, demanding extraordinary evidence for extraordinary claims. This disciplinary rift explains why the debate remains so perfectly balanced, so utterly unresolved after decades. It shows us that evidence alone is never enough. What we see is filtered through the lens of our training, our assumptions, and the very questions we are taught to ask. The stones of Yonaguni lie silent, while above the waves, the real story unfolds in the clash of these two magnificent, conflicting ways of understanding our world. And this intellectual battle has very real consequences, shaping not just theories but what we choose to explore next. The ocean floor is a hostile archive, protecting its secrets with immense pressure and perpetual darkness. Investigating a site like Yonaguni is a world away from a traditional archaeological dig on dry land. It is a slow, difficult, and often dangerous dance with a relentless environment. Every piece of evidence must be wrestled from the deep under severe constraints. Divers are not tourists. They are scientists operating on a strict biological clock, governed by the physics of decompression sickness. A single dive to the monument's depth allows for only a brief window of productive work, perhaps 20 or 30 minutes, before a lengthy and mandatory ascent to avoid serious health risks. This turns hours of investigation into a project of years, where progress is measured in centimeters of visibility and minutes of bottom time. Storms can shut down operations for weeks, and powerful currents can scour away newly exposed surfaces or shift sediment, constantly altering the very site they are trying to study. This is not a controlled excavation. It is a race against the sea itself. To overcome these barriers, researchers turn to advanced and expensive technology. Three-dimensional photogrammetry is a revolutionary tool. By taking thousands of overlapping photographs from every angle, specialists can stitch them together into a precise digital model of the entire formation. This allows them to study angles, measure depths, and examine surfaces in detail from the safety of a laboratory. Another instrument, called a sub-bottom profiler, acts like an underwater ultrasound, sending sound waves into the seabed to map structures buried beneath layers of sand and silt. Yet these tools are not magic wands. They require highly trained operators, vast amounts of funding, and they generate oceans of data that take months to process and interpret. They offer glimpses, not guarantees. These profound limitations create a fundamental asymmetry in the evidence. A geologist surveying the site from a surface vessel with broad-beam sonar might see the large-scale terraces and conclude the entire structure is a macro-scale natural feature. Their data set is complete for that purpose. An archaeologist, however, might suspect that a crucial clue lies in the fine detail of a single corner, a place where a potential tool mark or a carved symbol could be hiding. But reaching that specific spot, clearing it of marine growth, and documenting it thoroughly within a single short dive might be physically impossible. The environment thus becomes an active participant in the debate. It does not just hide the truth, it selectively reveals it, offering data that can support multiple conclusions. Both sides are forced to build their cases on fragmentary information, a puzzle where half the pieces may forever remain on the seafloor, buried or worn away. This inherent uncertainty is not a flaw in the science. It is the defining condition of underwater exploration, a reminder that some of history's greatest mysteries are kept in a vault we are only beginning to learn how to open. The story of Yonaguni is not an isolated mystery. It echoes across the globe in the warm, shallow waters of the Bahamas. Here lies the Bimini Road, a formation that serves as a powerful parallel and a cautionary tale. Discovered in the late 1960s, it consists of a long line of massive, rectangular limestone blocks, stretching for over half a mile across the sandy seabed. The blocks are arranged in a strikingly linear fashion, some appearing to be carefully fitted together. To many who first saw it, the conclusion was immediate and thrilling. This was a paved road, a causeway, perhaps even a wall from the fabled lost city of Atlantis, finally revealed. The initial wave of excitement was immense, capturing headlines and the public imagination. It seemed like the ultimate proof of a sunken, advanced civilization. Yet, as with Yonaguni, science soon stepped in with a cooler, more measured perspective. Detailed geological analysis revealed that the blocks were composed of beak rock, a type of limestone that naturally forms in horizontal layers in coastal environments. Over time, the weight of overlying sediment can cause this layered rock to fracture along these natural planes, creating clean, rectangular segments that can settle into orderly rows. The ocean's currents then shift the sand, exposing these blocks and giving the uncanny appearance of a constructed pathway. For most mainstream geologists, the case was closed. Bimini Road was a fascinating but entirely natural geological formation. But also like Yonaguni, the debate did not completely die. A dedicated group of researchers continued to point to specific details that, in their view, resisted the simple natural explanation. They highlighted blocks that seemed to be stacked in multiple layers, not just a single fractured sheet. They noted what appeared to be tool marks on some stones and argued that the alignment was too perfect, too purposeful, to be a mere accident of nature. This ongoing, quieter debate mirrors the one surrounding the Japanese monument almost perfectly. Both sites represent a clear pattern in how we engage with the unknown depths. A stunning underwater discovery is made. the initial, powerful human impulse is to see the hand of other humans, to connect it to our grandest myths of lost worlds. This is followed by a period of intense scientific scrutiny, where established geological processes offer a compelling counter-narrative. What emerges is not a quick resolution, but a prolonged tug of war between two compelling stories. One is a story of human history, dramatic and profound. The other is a story of planetary history, patient and awe-inspiring in its own right. The journey of Bimini Road teaches us a vital lesson about patience and methodology. It shows how the slow, meticulous work of cross-disciplinary investigation, combining geology, archaeology, and oceanography, is the only way to sift romance from reality. This same rigorous, often frustrating process is exactly what continues to unfold at Yonaguni today. The comparison reminds us that while our desire for lost cities is powerful, the truth, whether written by nature or by human hands, always demands a deeper, more disciplined kind of listening. Geometry is the language of intention. At Yonaguni, this language speaks through the monument's most compelling and controversial features. Proponents of the man-made theory point not just to isolated right angles, but to a larger, more profound order. They have mapped what appear to be deliberate alignments, where terraces and channels seem oriented towards specific points on the horizon. Some measurements suggest these alignments correspond to astronomical events, like the sunrise on a solstice. The overall layout, with its parallel walls, symmetrical platforms, and central axis, evokes a sense of planned architecture. The argument is powerful in its simplicity. While nature can create one perfect angle by chance through a clean fracture, what are the odds of an entire complex of interconnected geometric shapes and consistent orientations forming randomly? This perspective sees a designed blueprint, a spatial logic that implies a mind behind the monument, one that understood both geometry and the sky. Geologists hear this argument and offer a different interpretation grounded in the fundamental mechanics of the Earth itself. The region is a tectonic battleground where immense directional pressures have squeezed and fractured the bedrock over eons. This stress does not create random cracks. It creates systematic joint sets, a series of parallel and perpendicular fractures that slice through the stone like a grid. When erosion, both from ancient rainfall and modern currents, works along these pre-existing lines, the result can be an astonishingly regular landscape of orthogonal shapes. What looks like a planned city block of platforms is, in this view, simply the exposed skeleton of the Earth's own stressed crust. They then point to a quirk of human psychology known as pareidolia. This is our brain's relentless drive to find familiar patterns in random noise. We see a face on Mars, a dragon in a cloud, and yes, we can see temples in fractured sandstone. Our species is so adept at creating order that we often project it onto the world, especially when faced with something as awe-inspiring and mysterious as this underwater giant. This brings us to the core of the impasse, a question that transcends archaeology and geology. Are we discovering a pattern that was placed there, or are we imposing a pattern because we cannot help but see one? This tension lies at the very heart of the scientific method. Science begins with observation, but it must rigorously guard against the observer's own biases. One researcher might look at the formation and see clear evidence of design, their mind connecting the dots into a coherent, intentional picture. Another, trained to see the world through the lens of physical processes, will see a different picture entirely, one where every dot is explained by a natural cause. Both are looking at the same stones, both are using logic and evidence, yet they are arriving at opposite conclusions because their starting assumptions about what is possible shape what they perceive as real. This is not a failure of science, it is science in action, a slow and often contentious dialogue between observation and interpretation. The monument, in its silent grandeur, forces this dialogue into the open, challenging us to question not just what we are seeing, but how we see. It asks us to consider where the line truly lies between a masterpiece of nature and a monument of culture, and whether, in some profound cases, that line might be drawn more by our own minds than by the stones themselves. The stone's own story is told in microscopic detail. To move beyond what the eye can see, scientists turn the rock itself into evidence, slicing wafer-thin sections of the sandstone for analysis under powerful microscopes. This petrographic study examines the fundamental architecture of the material. It reveals the size and shape of the individual sand grains, the nature of the mineral cement that binds them together, and the intricate history written in tiny fractures and discoloration. The goal is to find a fingerprint, any telltale sign that human intervention altered the stone's natural life story. Researchers search for microscopic striations from stone or metal tools, for patches of thermal shock indicating controlled fire was used to fracture the rock, or for the introduction of foreign materials like plaster or mortar that would signal construction. In the case of the Yonaguni sandstone, these analyses paint a consistent picture. The rock is identified as Miocene in age, formed in a shallow sea tens of millions of years ago, long before humans walked the earth. The patterns of weathering, the dissolution of minerals, and the types of marine organisms encrusting its surface all align perfectly with known processes of natural submarine erosion over immense timescales. Crucially, at the microscopic level, no conclusive evidence of tool marks or artificial binding agents has been documented. From a strict materials science perspective, the stone behaves exactly as geologists would predict for a natural formation subjected to millennia of ocean currents. This body of evidence forms a strong, empirical pillar for the natural origin theory. It suggests that if you could rewind time, you would see the monument slowly emerging from the living rock through the patient, mindless work of water and chemistry, not through the directed labor of ancient builders. Yet, this very certainty is met with a philosophical counterpoint from those who remain unconvinced. They propose a different scenario. Imagine an ancient culture encountering this prominent, layered sandstone outcrop when it was still above water. Instead of quarrying new blocks and moving them, what if they simply modified what was already there? They might have used wooden wedges and water to split the rock along its natural joints, pecked away softer layers to create steps, or polished existing surfaces for ceremonial use. Such minimalist modification, working with the grain of the stone rather than against it, could leave remarkably little trace, especially after more than 10,000 years of relentless marine erosion. The sandstone itself, they argue, would not betray its brief encounter with human hands. In this view, the absence of microscopic proof is not definitive proof of absence. It simply means the evidence, if it ever existed, has been washed away by the very element that preserved the structure's grand form. This leaves us at an intriguing scientific crossroads, where the most advanced analysis of the material can deliver a clear answer that is simultaneously not the final word for everyone. Our screens have become the new frontier for this ancient mystery. The Yonaguni Formation did not just emerge from the ocean, it erupted into our collective consciousness through documentaries, magazine covers, and countless online discussions. This media spotlight is a powerful force, one that often reframes the scientific debate into a far more dramatic story. A typical television special might open with haunting music and shots of divers gliding past those imposing right angles, narrated by a voice promising the secrets of a lost civilization. The geological perspective, with its slower, more complex explanations about sandstone fracturing and tidal currents, rarely makes for a thrilling 2-minute segment. The result is a narrative tilt. The public is repeatedly shown the most architecturally compelling features, often isolated from the broader, less orderly context of the surrounding seabed. This selective presentation feeds a powerful desire for the spectacular, for tangible connections to legends like Atlantis. Online forums amplify this, creating communities where the possibility of a man-made origin is treated not as a hypothesis, but as an exciting truth waiting to be confirmed. This public perception has real-world consequences. Funding for underwater research is notoriously difficult to secure. A project framed as searching for a sunken city is far more likely to capture a network executive's attention or attract private investment than one proposing a detailed study of Miocene sandstone erosion patterns. This creates a subtle pressure where the quest for definitive proof of human hands can sometimes overshadow the quieter, more systematic work of understanding the site in its full geological and historical context. Scientists on both sides of the debate must navigate this charged landscape. They walk a tightrope between engaging public curiosity, which is vital for support, and maintaining rigorous scientific integrity, which requires acknowledging ambiguity and resisting sensational conclusions. The story of Yonaguni, therefore, exists in two parallel realms. One is the silent, aqueous world of stone and current. The other is the noisy, pixelated world of human storytelling and expectation. The tension between these two realms reminds us that in the modern age, a discovery is never just about the evidence. It is also about the story we choose to tell about it, and the profound ways that story can shape the very search for truth. Beyond the academic journals and diving expeditions, the fate of the site is shaped by more than just evidence. It exists within the living, breathing context of modern Japan, where economic and political considerations cast long shadows over the stones. The monument rests in Japanese territorial waters, placing its future in the hands of local and national authorities who must balance competing visions for its value. One path sees it as a spectacular natural wonder, a unique geological attraction that could form the centerpiece of a thriving ecotourism industry. Imagine a marine park built around this underwater marvel, drawing divers from around the world to witness its grandeur, boosting local economies in the remote island community of Yonaguni. This perspective favors accessibility and commercial potential, framing the site as a resource for the present. The alternative path is one of preservation and restriction. If the site were officially designated a significant archaeological monument, it would likely become protected cultural heritage. This status would bring strict limitations, potentially barring casual diving, commercial development, or any activity that might disturb the seabed. Research would become highly regulated, focused on conservation over tourism. This creates a tangible, real-world tension for decision-makers. The very classification of the site, natural versus cultural, is not an abstract academic exercise. It is a choice with direct consequences for local livelihoods and national policy. This reality can, at times, subtly influence the debate itself. A research proposal framed around proving the site's natural origins, which aligns with a tourism-friendly outcome, might find a more receptive audience in certain funding bodies or government offices. Conversely, a team seeking to prove its man-made status, which could trigger protective regulations, might face a more complex bureaucratic landscape. These are not accusations of bad faith, but an acknowledgement of how modern stakes can quietly amplify some scientific voices while others struggle for a platform. The implications run even deeper, touching upon narratives of identity and origin. The idea that an advanced, monumental culture could have existed on what is now Japanese soil, long before the rise of the known historical empires, carries a powerful symbolic weight. For some, it could become a point of profound cultural pride, a testament to an ancient and sophisticated lineage unique to the region. This taps into broader currents of nationalism and the human desire for a deep, distinguished heritage. Such sentiments can add emotional fuel to the archaeological argument, transforming a scientific hypothesis into a matter of cultural legacy. It reminds us that we never interpret the past in a vacuum. Our present-day hopes, our economic needs, and our search for identity are always there in the background, quietly asking the stones to tell a story that resonates with who we are today. The silent formation, then, becomes more than a geological or archaeological puzzle. It becomes a mirror, reflecting not only ancient possibilities, but also the complex modern world that is trying so hard to understand it. Yet the most convincing evidence for a human presence remains frustratingly absent. For any archaeologist, the definitive proof of a settlement is not found in the shape of the stones alone, but in the objects left behind. The smoking gun would be an artifact, something undeniably crafted by human hands and found in direct association with the formation itself. Imagine discovering a simple stone tool wedged between two terraces, a shard of pottery resting on a flat platform, or the remnants of a ceremonial hearth. A single such find, carefully documented in its original context, would silence the geological argument overnight and rewrite history. This is the holy grail that has driven decades of underwater exploration around the monument. And yet, despite numerous surveys and dives, that definitive object has never surfaced. No tools, no pottery, no traces of daily life have been recovered from the site. For geologists, this absence is not just a minor gap, it is a fatal flaw in the entire man-made hypothesis. They argue that any culture capable of shaping such a monumental site would have been a community, not just a passing group. Communities leave behind a material culture, a scattering of their everyday existence. Where are the chips of stone from the carving process? Where are the post holes for structures, or the middens of discarded shells and bones? The complete lack of this companion evidence, they contend, points overwhelmingly to a natural origin. The stones, in their view, were never lived among, only shaped by the indifferent forces of water and time. Those who believe in the site's human origins offer several compelling counterarguments to this silence. First, they point to the powerful and relentless ocean environment. The Yonaguni Channel is swept by strong currents that could have scoured any small, loose artifacts away centuries ago, burying them under shifting sands far from the monument or carrying them out into the deep ocean. What we see today might be just the bare, resilient bones of the site, with all the smaller, telltale evidence long since washed away. Second, they suggest the site's purpose may have been primarily ceremonial or spiritual, not a residential settlement. A place used for occasional rituals by people who lived elsewhere would naturally leave far fewer material traces than a permanent village. You would not expect to find cooking pots or tool workshops at a cathedral. Third, they draw a parallel to famous terrestrial archaeological sites. Many of the world's most significant ruins took decades, even centuries, of meticulous excavation before their key artifacts were unearthed. The search at Yonaguni, constrained by depth, time, and funding, is still in its relative infancy. The evidence, they believe, may simply be waiting, hidden under a layer of sediment or nestled in a crevice no diver has yet examined. This evidentiary gap, therefore, becomes a matter of perspective. Is it an empty void that proves the natural theory, or is it a puzzle box that has not yet been opened? The ongoing search for that one incontrovertible object continues, a quiet, hopeful scrutiny of the sand and stone, where the discovery of a single worked rock could change everything we think we know about the ancient Pacific. The implications of this debate reach far deeper than any sonar scan. If the stones of Yonaguni were shaped by human hands when the sea was distant, our entire narrative of human ascent would need a dramatic rewrite. The conventional timeline, taught for generations, places the dawn of monumental civilization around 5,000 years ago in the fertile river valleys of Mesopotamia and Egypt. This was when, we believe, humanity first gathered in large cities, developed writing, and erected lasting structures as a society. Yet if the formation is artificial, It points to a culture achieving comparable feats of stonework and maritime organization more than twice that long ago, in an era we currently label as the domain of hunter-gatherers. This is not merely adding an earlier chapter to the book of history. It suggests an entirely different volume may be missing, one that tells of a cycle of rise and fall we have forgotten. Such a possibility forces a humbling perspective on our own place in time. Modern civilization, with its global networks and digital memory, feels permanent. We document everything, assuming our legacy is secure. Yet the hypothetical builders of Yonaguni, if they existed, likely felt the same about their world. Their achievement, whatever it was ultimately surrendered to the sea, their story reduced to geological speculation and the faint echoes of myth. This invites a profound question about the fragility of knowledge itself. How much of the human story is written not on parchment or stone, but on landscapes that can be drowned, buried, or erased by a changing planet? Our historical record is not a complete archive, but a collection of fragments that survived by chance, preserved in specific, favorable conditions. The overwhelming majority of our past, especially from coastal societies vulnerable to rising waters, may be forever silent. This is not a story of doom, but one of perspective. Contemplating Yonaguni, regardless of which scientific camp you favor, is an exercise in expanding our sense of deep time. It asks us to look beyond the few millennia of recorded history and consider the vast 10,000-year stretches of human experience that lie in the shadows, illuminated only by rare and ambiguous finds like this one. Were there other pulses of cultural complexity that flared and faded, leaving behind only the most cryptic of clues? The debate compels us to hold our current understanding lightly, to remain open to the idea that the path of human progress may not be a simple upward line, but a more complex tapestry with threads we have yet to find. Ultimately, the true value of the Yonaguni monument may lie less in providing a definitive answer and more in the questions it keeps alive. It serves as a permanent underwater catalyst for wonder. It challenges the arrogance of assuming we have the past fully mapped. Whether a masterpiece of nature or a monument of humanity, it whispers the same essential truth, that our world holds depths of history we are only beginning to fathom. This reflective journey shifts the focus from proving a theory to appreciating the grand, mysterious scale of the human journey, a story still being written by both the forces of the earth and the enduring curiosity of those who seek to understand it. The stones hold their age like a closely guarded secret. To unlock it, scientists must turn to the most advanced dating techniques in our arsenal, but here they encounter a wall of silent, inorganic rock. Radiocarbon dating, the workhorse of archaeology, is utterly useless in this environment. It requires the presence of once living organic material like charcoal from a fire, bone fragments, or even ancient wood. The Yonaguni monument, however, presents only bare, unyielding sandstone scrubbed clean by the sea. There are no embedded artifacts, no charcoal layers, no biological time capsules to sample. This absence creates a fundamental investigative roadblock. Other sophisticated methods offer only partial glimpses. Uranium-thorium dating could theoretically be applied to any carbonate crusts, the thin mineral skins that form on submerged rock over time. But this technique has a critical limitation. It would only reveal when that specific crust formed, which could be thousands of years after the rock itself was shaped. It dates the scab, not the wound. Another method, thermoluminescence, could detect if stone had been heated intensely in the past, perhaps by ancient fires used to fracture rock. Yet no evidence of such thermal shock has been found in the monument stone. Without that trigger, the method remains silent. Faced with these barriers, geologists often rely on the broader clock of the planet itself. They use relative dating, placing the formation within a timeline written in ancient shorelines and ice cores. By cross-referencing the monument's depth with well-established sea level curves, they can say with confidence that the site was last above water roughly 10,000 years ago at the end of the last ice age. They also know the bedrock itself is Miocene, formed tens of millions of years in the past. These dates provide the stage, but not the action. They tell us when the stage was dry land, but not what, if anything, happened upon it. This impasse means the most critical question of all, the precise moment of the monument's shaping, remains shrouded in ambiguity. Both the geological and archaeological arguments must therefore build their cases on circumstantial chronology, a chain of inference rather than a single, definitive timestamp. The when becomes a shadow, as elusive and debated as the how. This technological limitation is a humbling reminder of the boundaries of our knowledge. Some ancient mysteries are not merely waiting to be solved. They are waiting for us to develop the tools to even ask the right questions. The silent endurance of the stone underscores a profound truth, that the past does not always surrender its secrets on demand. It requires not just curiosity, but a patience that spans generations, holding open the possibility that the key to understanding this underwater riddle has not yet been invented. The scientific debate over Yonaguni does not exist in a vacuum. It is flanked and sometimes overshadowed by a world of far more speculative ideas. This is the challenging terrain where legitimate inquiry meets fringe theory, and the lines can become dangerously blurred. On one end of the spectrum, you have trained archaeologists and geologists presenting competing but testable hypotheses based on observable evidence. On the other, some narratives leap far beyond the stones themselves, weaving the monument into tales of lost continents like Mu or Lemuria, ancient astronauts, or even pre-Ice Age civilizations wielding advanced, forgotten technologies. These ideas often fall under the umbrella of pseudoscience, not because they ask big questions, but because they start with a conclusion and gather only the evidence that seems to support it, while ignoring or dismissing everything that does not fit. For a mainstream researcher, this association creates a serious problem. When a credible academic cautiously suggests the site might show signs of human modification, their work can be unfairly lumped together with claims of extraterrestrial builders or magical energy fields. This guilt by association can lead other scientists to dismiss the entire archaeological argument out of hand, viewing it not as a scholarly disagreement but as a fringe fantasy. The result is a kind of intellectual pollution, where a serious hypothesis struggles to be heard over the noise of sensationalism. Navigating this landscape demands a specific skill, critical thinking. It asks us to hold two ideas in our minds at once. We must maintain a firm commitment to the standards of evidence, the slow, meticulous work of peer review and reproducible data. Yet we must also remain intellectually open, allowing for unconventional possibilities that are still grounded in reason and the physical world. The story of Yonaguni, therefore, becomes more than a geological puzzle. It transforms into a real-world lesson in how we separate signal from noise. It shows us that the pursuit of lost history is always a dance between bold imagination and rigorous skepticism, and that the most enduring truths are usually found not at the extremes, but in the careful, often frustrating, examination of what the evidence actually allows us to say. But the monument story is not locked in the past. It pulses with life in the present. Regardless of the endless debate over its creation, the Yonaguni Formation has undergone a stunning transformation. It is no longer just a collection of silent stones. It has become a vibrant, thriving metropolis for the ocean. The sheer vertical faces and deep crevices provide perfect shelter. The flat terraces offer hunting grounds and gathering places. Over centuries, marine organisms have claimed every surface, building a living skin of colorful soft corals, sponges, and anemones. This has turned the structure into a world-class artificial reef, an accidental sanctuary of breathtaking biodiversity. schools of tropical fish swirl around the pillars like living confetti. Seasonal congregations of majestic hammerhead sharks circle the deeper waters, drawn by the rich ecosystem the monument supports. For divers from across the globe, this is the true magic of Yonaguni. They come not necessarily to solve an archaeological riddle, but to witness a natural spectacle, to glide through a submerged city teeming with life. This ecological reality adds a profound new layer to the monument's identity. It forces us to see it not through a single lens, but through a prism of interconnected meanings. If the formation is purely natural, then it represents a spectacular biological hotspot created by the patient hand of geology. The Earth, through fracture and erosion, sculpted a habitat that would one day cradle an entire marine community. It is a testament to how non-living processes can seed the conditions for immense, vibrant life. If, however, ancient hands did shape these stones, then the narrative expands in a remarkable direction. It would mean that a culture, for reasons lost to time, performed an act of unintentional environmental engineering on a monumental scale. They created a structure that, over 10,000 years, would become one of the ocean's great gathering places. Their legacy would not be written texts or golden artifacts, but a living, breathing reef that has sustained generations of marine life. This perspective gently shifts the focus. It asks us to appreciate the formation not solely for what it might have been at its beginning, but for what it has undeniably become. It is a sanctuary, a haven, a cornerstone of a complex underwater world. This ecological value exists independently of human history, yet is deeply entangled with it. The monument, in its silent endurance, has given back to the planet in a way its builders, whether tectonic or human, could never have foreseen. It reminds us that the most enduring legacies are often those that continue to nurture life long after their original purpose has faded into the deep. A new kind of laboratory now probes the monument's origins. Far from the ocean currents, researchers harness the power of simulation, constructing digital twins of the formation to stress-test every theory. This is not about finding a single artifact, but about running countless experiments in the span of a computer's processing cycle. Geologists begin with the raw ingredients of the ancient landscape. They program a virtual block of Miocene sandstone, embedding within its code the precise layering and mineral weaknesses of the real rock. Then they introduce the known forces. They apply millennia of tectonic pressure, simulating the immense directional stress that fractures stone along systematic planes. They unleash simulated millennia of rainfall, wind, and crucially, the relentless sandblasting of tidal currents. The question is simple. If we let these verified, measurable processes run for 10,000 virtual years on this specific type of stone in this specific location, what emerges on the screen? Does the model spontaneously generate clean terraces and sharp angles, or does it produce a more chaotic, rounded form? Each successful simulation that ends with a Yonaguni-like shape is a powerful argument. It demonstrates that the monument could be a highly probable, even expected, outcome of natural forces we understand completely. It suggests we are not seeing a statistical miracle, but a masterpiece of planetary probability. Meanwhile, architects and archaeologists approach the same digital model from the opposite direction. They import the precise three-dimensional scan of the site into their software, treating it not as a geological specimen but as a potential built environment. Their tools allow them to analyze sight lines, measure the ergonomics of the so-called staircases, and test the structural integrity of the platforms under load. They search for underlying geometric principles, a consistent unit of measurement, or alignments that serve a practical or ceremonial function. Could a community have logically used this space? Does its layout compare to known, undisputed ancient sites that served as gathering places or ceremonial centers? Their simulations ask whether the pattern of the place reflects a human logic of use. These digital experiments will never shout a definitive answer. They deal in shades of probability, not proof, but they offer something revolutionary, a common ground built on data. They move the debate from a clash of interpretations toward a shared process of testing. A geological model that consistently fails to produce the monument's key features would force a re-examination of the natural theory. An architectural analysis that finds no coherent human usable logic would seriously undermine the archaeological claim. This is the quiet, methodical next chapter of the mystery. It is a promise that the stones may yet speak, not through a dramatic discovery, but through the patient, predictive language of code. Every great scientific mystery is ultimately a story about people. Behind the sonar scans and academic papers are individuals whose lives have become intertwined with the stones beneath the waves. Two figures, in particular, stand as opposing pillars in the Yonaguni debate, each bringing a lifetime of expertise and personal conviction to the question. On one side is Masaaki Kimura, a professor of marine geology at the University of the Ryukyus. For decades, he has been the site's most dedicated investigator, conducting hundreds of dives and compiling meticulous surveys. His journey is one of dramatic conversion. Initially skeptical, Kimura's close, repeated observations slowly convinced him that the complexity and concentration of features defied a purely natural explanation. He became the foremost proponent of the man-made theory, authoring books and giving lectures that framed the monument as a crucial, overlooked piece of human history. His passion is rooted in a deep connection to the local waters and a belief that the site holds a key to understanding Japan's ancient past. On the other side is Robert Schoch, a geologist whose work on revising the dating of the Great Sphinx brought him international attention. Invited to dive at Yonaguni, he approached the formation with a geologist's eye for large-scale processes. After his examination, he publicly and firmly concluded that the monument was a natural structure, shaped by the well-understood forces of tectonic activity and erosion. His credibility, built on challenging orthodox views elsewhere, gave significant weight to the natural origin argument. The dynamic between these two researchers is more than a simple disagreement. It is a decades-long dialogue that has defined the public understanding of the site. Their debates in documentaries, their contrasting interpretations in publications, and their personal commitment have given the mystery its human face. This reminds us that science is not a cold, mechanical process of facts entering a machine and truth emerging. It is a deeply human endeavor, driven by curiosity, shaped by experience, and sometimes complicated by stubbornness. Kimura's evolving viewpoint shows how evidence can change a mind, while Schoch's steadfast analysis demonstrates the power of disciplinary perspective. Their story adds a layer of drama to the technical arguments, because it reveals that the pursuit of truth is often a personal journey, a relentless wrestling match between an individual's intellect and the enigmatic silence of the world. We are drawn to such mysteries not just for answers, but for the profound human quest they represent. Perhaps the ultimate lesson of Yonaguni lies not in the answer, but in the question itself. This prolonged stalemate between geology and archaeology points toward a potential, though challenging, path forward. What if, instead of separate investigations that often confirm pre-existing biases, these two disciplines designed and executed a single research project together from the very beginning? True interdisciplinary collaboration would require a fundamental shift in approach. Imagine a joint team of geologists and archaeologists sitting down before any dive, establishing a set of agreed-upon criteria. They would decide in advance what specific features would constitute definitive evidence for a natural process and what would be undeniable proof of human modification. This shared framework would become their common rulebook, a way to move beyond talking past each other. The fieldwork itself would be a fusion of methods. A geological core sample, extracted to analyze the deep history of the rock, would be taken from the same precise location where an archaeologist maps the microstratigraphy of surrounding sediments, searching for any cultural layer. The three-dimensional scans used to model erosion patterns would also be analyzed for spatial organization and potential alignments. They would share technologies, budgets, and most importantly, their distinct ways of seeing. Of course, this is far easier said than done. Each field has its own specialized language, its own deeply ingrained priorities, and its own institutional cultures. A geologist's primary interest might be the tectonic history of the entire shelf, while an archaeologist focuses on a single, potentially worked corner. Merging these visions requires genuine humility and a shared commitment to the mystery over departmental victory. Yet, this kind of cooperation may be the only way to move beyond the current divide. The Yonaguni monument, in its silent grandeur, thus becomes more than an archaeological or geological puzzle. It stands as a profound test case for modern science. It asks whether our siloed disciplines, for all their specialized strength, can learn to speak a common language when faced with a common enigma. Can they unite not to prove a point, but to solve a captivating, shared question? The outcome could point toward a more integrated, and perhaps more insightful, future for exploring the deepest chapters of our past, reminding us that some truths are only visible when we are willing to combine our different lights. The Pacific Ocean does not hold a monopoly on submerged mysteries. Yonaguni is a single piece in a vast, global puzzle scattered across the sunken edges of our continents. From the deep waters off western Cuba, where sonar has revealed startling geometric formations resembling vast urban layouts, to the strange, circular anomaly resting on the Baltic seafloor that some have called a crashed UFO, but others see as a glacial deposit, our planet's shallow shelves are dotted with tantalizing sonar ghosts. Each new blip on a screen, each unexpected shape emerging from the abyssal dark, reignites the exact same fiery debate that surrounds the Japanese monument. Is it a trick of geology or a relic of history? The discovery of these sites is accelerating, yet our understanding lags far behind, often trapped in the same cycle of instant hype followed by entrenched skepticism. This is precisely why the long, contentious scrutiny of Yonaguni is so valuable. It is no longer just a local enigma. It has become a global case study, a methodological template for how we should and should not approach every new underwater anomaly we find. The first lesson is one of urgency and discipline. When a new formation is discovered, the immediate response must be a coordinated, multidisciplinary investigation. Imagine a team arriving not with a predetermined answer, but with a shared toolkit. Geologists, archaeologists, oceanographers, and materials scientists would survey the site together from day one, collecting overlapping data sets before public speculation hardens into competing dogmas. This collaborative front could prevent the decades of polarized argument that has characterized the Yonaguni story, where separate fields built separate cases in isolation. The second, more pressing lesson is one of preservation. These submerged landscapes are archives written in stone and sediment, but they are profoundly fragile. Industrial trawling can scrape away centuries of sediment in hours, potentially burying or destroying delicate evidence. The search for deep-sea minerals and the laying of submarine cables pose direct threats. Even the broader shifts of climate change, altering ocean chemistry and current patterns, can accelerate the erosion of these sites. We are in a race against time and human activity, exploring these hidden chapters of our planet's story before they are lost to the deep for a second and final time. The true legacy of the Yonaguni debate, therefore, transcends the stones themselves. It provides a manual for humility and rigor. It teaches us to question our first impressions, to balance our sense of wonder with analytical patience, and to recognize that the deepest truths often lie at the intersection of different ways of knowing. The protocols developed here, the hard lessons learned about evidence and perception, are now exportable. They form a crucial chapter in the guidebook for how humanity will investigate its own drowned prehistory on a global scale, a process that has only just begun. We emerge from this deep water debate not with a verdict but with a deeper kind of understanding. The true legacy of this underwater formation may have little to do with settling an argument. Its greatest gift is the way it illuminates the very process of discovery itself. This is not a story about who is right or wrong. It is a story about how we search for truth when the evidence is submerged in both water and time. The stones, in their silent endurance, have become a catalyst for a far more important conversation, one about the limits of our knowledge and the boundless nature of our curiosity. They remind us that some of history's most profound questions are not meant to be answered quickly, but to be held, examined, and appreciated for their ability to expand our minds. This is where the real value of the mystery lies. It lives in the space between the known and the unknown, a space that fuels scientific progress and human wonder in equal measure. Whether shaped by tectonic force or ancient hands, the formation has achieved something remarkable. It has united geologists and archaeologists, skeptics and believers, in a shared act of looking. They may see different things, but they are all looking, and that collective gaze is a testament to our enduring need to make sense of the world. This shared quest is far more significant than any single conclusion. It speaks to a fundamental human drive to explore the edges of our understanding, to push against the boundaries of our timelines, and to listen for whispers from a past that is far less settled than we often assume. The monument's ultimate message might be one of humility. It asks us to sit comfortably with uncertainty, to accept that the past does not always surrender its secrets on our schedule, and to find inspiration in the questions themselves. So let this enduring enigma be a call to keep looking, to keep questioning, and to approach the world's hidden depths with both an open mind and a critical eye. The journey of discovery is never truly over. What do you believe lies beneath the waves? Share your thoughts, and as always, thank you for exploring history's greatest puzzles with us.